Okay, so for you volleyball people, we're so sorry you're not here. But here we go. This is example 4. We're starting with quadratics. So the first thing I want to make sure that you're aware of is that when you are solving a quadratic, if you want to solve it by factoring or any of the methods we're going to use, you have to have it equal to 0. You can't try to factor the left-hand side and then go x, like you can't do this. You can't go x times x plus 5 equals 24 and then split it into like x equals 24, x plus 5. It doesn't work that way. No. So what we have to do is first and foremost make sure it's in the right form, which means it has to be equated to 0. How do I do that? Subtract 24 from both sides. Obviously, I cannot combine variables with numbers when I'm subtracting, so you don't want to say like 5 minus 24 is like negative 19, for example. It's not, you just want to rewrite it like that. Now we can employ our factoring techniques to actually solve this. So we're going to say x times x is x squared. Anyone have ideas for me for factors of 24 that will yield a 5? 4 and 6 will not yield a 5. 8 and 3.
Wow.
8 times 3 is 24. We want a positive 5, so we want to have a negative 3 here, right? So we can have 8x minus 3x, which will give us the 5x that we're looking for. So then that means that this is going to factor out to x plus 8 and x minus 3 equal to 0. And now because it's equal to 0, you can employ the zero product property, which states that either x plus 8 equals 0 or x minus 3 equals 0. We've done this in algebra 2. So your solutions would be negative 8 and positive 3. Okay? And getting out of the way so that you can see. Are we good? So I'm going to go on to the next one, yes? So it's important that you understand the different types of quadratics. This one has 3 terms. In other words, it has this middle term here. What we're about to show you right now is different in that way. So if you want to put this in your notes, that's something you might forget later. When the middle term is missing, and only when the middle term is missing, then you can solve it a different way. You don't have to use factoring. So you'll notice that in both of these cases, the middle term is missing. There's no x to the 1 power. There's no linear term. So you could subtract 5, but it wouldn't necessarily help. Okay, in this case, also, it's the same thing. It's missing the middle term. So when you have these kinds of cases, and if you remember when we did algebra 2, there was 5 different ways to solve quadratics. One of them was by graphing. Boo, that's not fun. The other one was extracting square roots, which is what we're about to do right now. Extracting square roots is a fancy way of saying take the square root of both sides. Okay? The third one was factoring. Fourth one was completing the square. And the fifth one was quadratic formula. By the way, we're going to do them all except for the graphing one today. So, first thing we're going to do is extract square roots. So that means that you want to have the squared term by itself isolated. This is already isolated. That's already isolated. So we're going to go square root, square root. Do not forget that when you do that, you have a positive and a negative case. So it's plus or minus root 5. That difficult. That's sarcasm right there. It's not really that difficult at all.
Wow.
Yes, sir.
What if you subtract 5 from both sides?
Okay, then what?
And then, like, you factor.
You can factor, but you're not going to get any factors of 5 that will multiply to get 0. Unless you use radicals, like plus or minus root 5. So, yes, technically you could do that, but it's not going to be any simpler. It's going to be more complicated. All right, so then we have this guy, and same thing, because the squared part is already isolated. So now we're going to get x minus 4 because the square root will cancel, and you're going to have plus or minus root 5 again. But this time we haven't isolated x just yet. There's still something with the x. What's over there?
-4.
The -4 needs to come over to the other side. So x equals 4 plus or minus root 5. Those are your two solutions for that one. And you can write it just like that. If you want to get all nifty, you can go 4 plus root 5 and 4 minus root 5, but it's totally okay for you to go 4 plus or minus root 5. Next up, we're going to do, so far we've done extracting square roots, and we've done a factoring one, correct? The first one we did was a factoring one. So now we're going to go to example 6, and we're going to employ completing the square. In my opinion, probably the most difficult. Not because it's supposed to be, but because, I don't know, people just don't like it. I don't know why, but they don't, so beware. Be my guest, be my guest. X squared minus 8x plus 13 equals 0. And we'll just do that for now. There's a part B, but we'll do that afterwards. So, going back to Watson's whole theory earlier, you're supposed to try to factor it first thing first, okay? 13 is a prime number. So we don't have very many options with factors here. They're pretty much either 1 and 13 or 1 and 13. Okay, so to try to get an 8 from that is not going to happen. 13 minus 1 is 12, 13 plus 1 is 14. You're not going to get an 8, no matter how you slice it, okay? So what we're trying to do is we want to get this quadratic to look like the previous example. We want it to be squared so that we can just take the square to both sides and call it a day. So that's what we're going to do with completing the square. So I will tell you right now, and the camera will prove, that when you get your quiz, if it tells you to solve it by completing the square, you have to employ that method. In the future, you can solve it however you want, but you at least have to know how to do each method. Okay, so how do we complete the square? First thing you want to do is get rid of your constant term to the other side. So we're going to go x squared minus 8x blank equals negative 13. All right? And by the way, you'll notice that in part A, it's going to be easier than part B because part A doesn't have a constant or doesn't have a coefficient in front of x squared. The coefficient here is 1. These are the easiest cases. This will be different when you have a number in front of the x squared, which will be part B. So for now, let's just, so step number 1, if you're one of those people that wants to put steps down, if you don't have your Algebra 2 notebook with you anymore, first step is to move the constant term to the other side, creating this blank. So I call it completing the square. It's not a square now, and we need to complete it by putting something in there that will hopefully help it be complete. Okay? So that process, the next step is to take your middle term, okay? So we're going to take the negative 8 divided by 2. Always divided by 2. If it's negative, then negative divided by 2. If it's positive, then positive divided by 2. But it's always divided by 2. In this case, I have a negative 8, so negative divided by 2 is going to give me negative 4. Okay, that's step number 2. Take the middle term, divide it by 2. We're still not done. After you divide by 2, you square the result. So my result was negative 4. I now square that, and it becomes 16. Believe it or not, 16 is my magic number. 16 is what needs to go in this blank. But as you well know, you can't keep an equation balanced if you add 16 to one side and don't add it to the other side. Right?
Yes.
It's like those little scale things that is going to go, you put 16 rocks and it's going to, tip over. The idea of this equal sign is that they're both the same right now. They're balanced. And if I add 16 to the left, I have to also add 16 to the right. Okay? Now, technically, the next step is to factor the left-hand side. Because what we just did is make it so that now it's factorable. The 13 wasn't factorable. But now that we put a 16 there, the left-hand side should be factorable. So we do that. And I want to just remind you right now that what I'm about to do, hopefully, eventually as you progress, you will no longer need to do. I need to do it at least once so you can see that I'm not lying to you. So we're going to factor it. It's going to be x times x. 16 is going to be 4 times 4. And if I make those both negative, I'll get negative 4x minus 4x is negative 8x. So it just so happens, all like magic like, that I get x minus 4 and x minus 4. My factors are x minus 4 and x minus 4, or otherwise known as x minus 4 squared. It is no coincidence, okay, it's not a coincidence, not a coinky-dink, that that negative 4 happens to be the exact same negative 4 that was right there. So when I said earlier that you're going to skip a step, in the future, you can skip this factoring step. Because if you do this all correctly, the idea is that you have guaranteed, you know what a guarantee is, right? It's like, it's true or your money back kind of thing. Okay? It's guaranteed that you're going to get a square. That's why it's called completing the square. It's not a square now. We put that number in there. Now it's a square. It's guaranteed. So that number that goes in the parentheses will always be this number before you squared it. So basically the middle term divided by 2 will always be what goes there. It won't always be an integer. Sometimes it'll be a fraction, but it will always go there. Okay? So now we can continue solving. So we're going to put, well, it's like we didn't decide what color I wanted to be. We're going to go 16 minus 13. 3, so that's still 3. So now you can see how this is very similar to the previous example. We're going to square root. You're going to get x minus 4 equals plus or minus root 3. And then you're going to want to subtract, or not subtract, add 4 to both sides. And your final answer will be x equals 4 plus or minus root 3. Alrighty? So now, are you guys okay with that? You understand the process?
I am.
Move the constant over. Take the middle term, divide it by 2. Square the result. Add that to the blank. Factor. Solve. Yay. Alright, well, now we're going to make things just a little bit more complicated. Because in part B, we have something slightly different. Okay, calm down. It's getting crazy on me. In part B, we have a coefficient in front of the x squared that's going to screw with our brain a little bit. Okay, again, your first instinct should be to factor, but you recognize upon doing that the factors of 6 are 1 and 6 and 2 and 3. And you're not going to get negative 12 from those small numbers, right? So we can't do that. But we want to do this whole completing the square thing, but we can't just move the 6 over. I mean, you could, but it's not all you have to do. You have to divide by whatever's in front of the x squared. I will say that again. You always divide by whatever's in front of the x squared. It doesn't matter if 3 doesn't go in evenly to everything. In this case, it happens to go in evenly to both. That won't always happen, but that doesn't matter. You will always divide by whatever is in front of the x squared because you always want to end up with 1x squared. It doesn't matter if you end up with fractions over here. It makes things more complicated, but it doesn't matter. You want to have 1x squared. Like we had in the previous example. You want it to be 1x squared. So that kind of forces us to have to divide by the 3. Now you can do this now, or you can do it after you move the 6, and that doesn't really matter. I'm just going to go ahead and do it now. So I'm going to get x squared, 12 divided by 3 is 4, and then plus 2. And now I basically have the same exact problem that I had earlier. Only this time, we're going to use our shortcut, right? We're not gonna do that whole factoring thing, because I only have to do it once. So we're gonna move the 2 over. Si, senor? Do you remember what the next step was?
Divide by 2.
Divide what by 2?
The middle term.
The middle term, which is?
4.
Negative 4.
I mean, 4.
No, negative 4. Negative 4 divided by 2 is negative 2. This is an important number, remember?
Yeah.
When I factor it later, this is going to be important. So that little guy squared is
4.
positive 4. So now we're going to put a plus 4. We're going to balance our equation plus 4. And we're going to end up with, who can tell me what it's going to be factored? What's the factored form? X minus 2 quantity squared. The minus 2, again, coming from this number that I circled earlier. And then, of course, 4 minus 2 here is just 2. And now we're golden. Golden, kid.
All right.
Square root both sides. Square root. X minus 2 equals plus or minus root 2. Add dos to both lados. X equals 2 plus or minus root 2.
It's a gold boy.
Gold boy, gold boy. So when you have a coefficient, I don't know why I said that. When you have a coefficient in front of x squared, the only added step is that you have to divide by that coefficient throughout the whole problem to get what you want there. Alrighty? So we did factoring, we did extracting square roots, completing the square. We're not doing graphing. What's missing?
The
You got
the
it.
other answer. The other one.
What's the other one?
Yeah, you got it, dude.
You got it. You're close, right?
Come on, it's like my favorite. It's everybody's favorite.
Difference. Johnny, you know it, right?
Completing the square?
Quadratic formula.
Oh,
Because there's a song.
Thank you, people.
There's a whole song. Come
Did
on
you wish
now.
you knew it was
Elder Williams.
all over you. Hey.
Yes, that song, it's so great. Okay, for the quadratic formula, you probably should know it. If you don't know the quadratic formula, we will sing it together. X equals negative b plus or minus radical b squared minus 4ac, all divided by 2a. Yay, okay? So a, b, and c are the coefficients of a quadratic in standard form. This is a quadratic in standard form, so we have A, B, and C. So what we're going to do first is go ahead and identify that A is 3, B is negative 5, and C is negative 1. And then literally plug it in. Plug it in, plug it in. You guys don't know about plug it in, plug it in.
I know what that is.
It was like a product, like a Blade plug-in, the air fresheners and stuff. Anyway, so negative B plus or minus. By the way, I do this all the time. It really helps me out a lot. I know you can't see. Give me a sec. I put parentheses wherever there's a variable, so that later I can plug in what that variable is supposed to be. This is very helpful, especially for that negative b. Because oftentimes, because it says negative b, and you see that b is negative, you just put negative 5. But you would be wrong. Because actually, when you put a negative 5 in those parentheses, that negative and that negative will make it positive 5. So just be careful. B squared, we're going to put a b in there. A is 3, C was negative 1, and A was 3. So we're going to get positive 5 square root of 25 plus, because you have a negative times a negative, 4 times 3 is 12, and then divide by 6.
Oh, yeah, that one.
What's 25 plus 12?
37.
37. I'm pretty sure 37 is a prime number, so we can't break that down. But that would be your answer. X equals 5 plus root 37 divided by 6. And x equals 5 minus root 37 divided by 6. Or just leave it like that. 5 plus or minus the square root of 37, all divided by 6. The quadratic formula can give you all kinds of interesting solutions. In this case, we get two irrational solutions because the square root of 37 is like this irrational number. But you can also get normal integers or normal rational numbers as a solution. So am I done with this guy? So we're going to go to part B. And B is going to be 4x squared plus 12x plus 9 equal to 0. So in this case, my A is,
4.
and B is,
12.
and C is,
9.
what? Okay. Negative B plus or minus radical B squared.
Minus.
4AC all divided by 2A. I went ahead and squared 12 already. B squared is 144. 4 times 4 is 16. And 16 times 9. Anybody? I don't even know what that is.
582.
Wow, let's see if he's right.
Yeah.
My guess is he is, but
No,
no, it's 144. Bad you. So we're gonna get, this is all gonna be 144. So 144 minus 144 is 0. So that's nice because you're gonna end up with negative 12 plus or minus 0 over 8. Or basically just negative 12 over 8. So you're only gonna end up with one solution. And 4 goes into 12,
3 times.
and 4 goes into 8,
3 times.
negative 3 halves.
4.
So you only got one solution. I want you to be very observant here. In the previous example, we ended up with 2 solutions, right? 2. In this case, we have one solution. Why did that happen? Because you ended up with the square root of 0. You only got one solution. In the previous example, we ended up with a positive number. So you got 2 real solutions. My guess is that the next one's going to be imaginary solutions because you're going to end up with a negative in this square root thing. But first, let's finish writing down B. Let me know when I can move it to the next one.
We can move it. You can go.
And then we're going to take a break.
Really?
Kind of.
Do we get a test back, quiz back today?
No. I have only graded 3 of them.
Oh, okay.
That's,
Can I move the
yes,
Yes.
me.
C? I must like red because it keeps going to red. Where is C? X squared plus 2x plus 2. We start off the same way, identifying what A, B, and C are. A is 1, B is 2, C is also 2. So when I plug into my formula, x equals negative b plus or minus radical b squared is 4, 2 squared is 4, minus 4 times a times c, all divided by 2a. So what's going to happen here is you're going to get 4 times 1 is 4, and that times 2 is 8. So this is 8. 4 minus 8 is?
Negative 8. No, I mean 4.
Negative 4, thank you.
Here's 4.
All divided by 2. Now the square root of 4 we know is 2.
Negative.
But because of that negative, you're going to get 2i. It's imaginary, right? 2i. And then because you have this 2 goes into all those numbers, you could actually reduce this to -1 because -2 divided by 2 is -1. And then plus or minus 2 divided by 2 is just +1 and you can get that. So x equals -1 plus or minus I, but these are both still 2 solutions, but they're imaginary solutions. And at this point, we're not yet dealing with imaginary, so I'm pretty sure that when you get to your WebAssign, they're not going to want you to plug this in. Trust me, the day is coming where we will deal with imaginary numbers. Right now, the second you see negative right there, you just tell WebAssign no solution. Because there is no real solution. The solutions are imaginary. So this would be a case of no solution. Alrighty?